Hello, hello everyone. GM. Good morning, afternoon, good evening, night. Welcome everyone for lesson 20, where we're going to start building a challenge of a lottery to review these things about randomness that we saw yesterday, some other techniques that we picked here and there. We're going to do a review about building a project too, to prepare you for this weekend project. That is going to be like a review of last weekend project, but in a lighter way, in a quicker way. Show that for you. Where's the weekend project? Should be at the bottom. Yes. So the weekend project is going to be building the app, a front-end app only. We are not going to need a backend this time, just a front-end using any framework of your preference, anything that you would like for you to integrate with this smart contract for playing a lottery. Okay. Sure. So it is smaller than last weekend project, and it's a review for getting you in in order for building your final project that should have an interface, should be using some smart code integration, some of the things that we saw in this bootcamp. Okay. So to prepare you for the weekend project, I'm going to build this smart contract and this script side by side with you today, showing the things slowly. We're not going to have time to complete everything today. I'm going to more like do the outline, but I have the solutions. Okay. If you scroll down uh, after these references here, I have pasted a solution for the smart contract with some annotations so that you know where things are going, a solution for the script to operate that smart contract. So should be quite easy to follow, okay? Even though I want to incentivize, I want to, um, uh, what's the best word? I want to push you towards, I want to nudge you towards doing this whole smart contract from scratch without looking at the solution. But since this is a requirement for the weekend project, you have the solution there, so no stress. Okay. Laurent, you want to ask a question before we begin?
It's not a question, it's a suggestion. In the lesson yesterday, you were copy pasting a folder in order to create the lesson of yesterday. And when I did the same, I had some issue with the config. So, is it possible today, if you have to create a new folder, a new repository, to do everything with the CLI? I think it will be a nice refresh for some people, at least for me. Does it
Okay.
make sense, my request?
Yes, I understand. I expected that by this time we would have proficiency with this because we created 1, 2, 3, 4, 5, 6, 7,
I
8,
know,
9,
but
twelve projects.
every project is different. Sometimes we play with the config, with the compiler. So we have a lot of projects, but we don't have a target one which is totally clean. So
Like a cookie cutter project, like we did on lesson 5. This is the one that you're looking for, Laurent?
no, what I'm saying is I may have not as many as you, first of all. Yesterday I did copy paste the project 6, for instance, and I spent half an hour to try to make it work during the lesson. So I was suggesting to recreate one from
Okay,
scratch.
we can.
But if you don't, okay, at least it's
No,
my
we can. We can. Don't worry.
at least it
I'm
will help me.
no,
Laurent,
yes,
I
I'm
just
I'm
put
thinking
a
that at some point you should have a project that you're copying back and forth. I guess that you didn't build that on your side, and then it's snowballing. I know it happens, and probably you're not
Yeah,
the only one.
exactly. So I'm not sure exactly. So
So you
yeah.
should have a project like this project one or something where you have the hot.config, a package.json, and a .env, right? One that you use it in your weekend projects, maybe, right?
So yeah, sorry, I thought I was on mute. Yeah, but sometimes, I play with the project and I change some config, and the config is not clean anymore, or I use another test net. There is always a reason to have an error. and not to be able to follow what you are doing. At least yesterday it was a pain for me. Half an hour trying to make it run.
No, you made the point very well. I'm just asking if you have a project like this in your computer where you can copy and paste it forward. If not, you should create one that is called a boilerplate, a cookie cutter project. Some people call like that you can just copy and paste it over for starting your
Yeah,
project.
yeah, I get the idea. So to answer, no, I don't have one like this, and I think it's a good idea to have one ready.
Okay, let me point you in 1 minute and do that very quickly for us to save time for today's lesson. And the instructions that you're looking for are in lesson 5. If you pick lesson 5, remember I told that this is the most important lesson in the story of the bootcamp.
Ah, yeah.
So
Okay.
so
So bye
so
bye.
so this is the step by step. I can do it very very quickly for us today, like 1 minute, and it's a good investment. I know that more people might have the same question. So let's invest in that direction. Every time one of you asks this question, any question, the probability of all the people here, we have 33 participants having the same question is very high, like more than 50% or so. So it is worthy investing time in all of those questions. So I'm going to create a new project. I'm going to start from here, make a directory of a new project of like lottery. Okay, and then CD lottery. And then I'm going to do this command here, npm init. I'm going to do with a flag of Y just to get everything confirmed for me instantly. And then I'm going to do the npm install save with hard installed locally. Okay. Arda commented that I'm going to need the .env, the mocha rc.json. Yes, I have those steps here. So instead of creating them from scratch, we can copy from all the repositories, which is even better. But right now, I'm going to follow for you, Laurent, and anyone else that might have this problem. After the installation finished, I'm going to pick hard project and run the command of init, picking the option with VM. I know that this morning we picked ethers, but we don't need to go with ethers anymore. We can fall back to a VM. Ethers would work normally, but it's not needed. We can go back with the option of TypeScript project with VM, and then this is going to initialize all of the files that we need for today. Okay, all of the hard files that we need for today. Okay, we need the .env and mock rc, like I mentioned. The explanation for those are here. Okay. Up to this point, Laurent, you know what I'm doing. You can follow those instructions here from lesson 5.
Yeah, yeah, yeah.
Okay. And don't feel pressured. If you have a question, don't worry, tell me. I can get you covered. Let's create this file, mockrc.json, very quickly. Let me open a new tab as this goes. Let me create with nano. And then I'm going to paste this. Then save this file. Let me create a .env too. So I created this mockrc.json. I created this .env. So the files are there. Let me just see if I save it. I save it. Okay. Now, if I run things like compile or test or something like that, it should work out of the box. npx hard compile. It should work. See, these scripts, they should work. Okay, compile successfully. Good. At the end, for me to clean up before starting, I'm going to do these things. This will need to be RF. Okay. Now we can start on this project. Took me 3 minutes almost. Okay, so Lauren, this is the step by step that you asked, right?
Yeah. Thanks for this, Matteo.
Good, no worries, no worries. And then Arda, you commented about the .env mock RC would be good if we could copy and paste from other projects, yes. And Ivan, you added that you can optionally add more packages. For example, Open Zeppelin contracts, oops, didn't copy. Open Zeppelin contracts, this is a package we use a lot. We're going to use this today too. One. Another one that you use a lot, .env. So you can pick all of those packages. Oh, I disconnected my monitors here. Dang. Sorry, people. Just 1 second. I messed up something that I shouldn't. Oh, dang. Sorry. Ah, my bad. Ah, sorry about this, people. I have 2 monitors here, but I ended up tripling my cable and I disconnected them. Maybe I can follow the lesson without them. Let me see if I can get them back real quick.
Take your time. And then in Discord, send us your setup picture.
I guess do I have a mute here? I guess it's done. Let me see if we can you hear me well, by the way? My audio is flickering here. Okay, I have my monitors back. Good. Sorry about that.
Why would you clear the template files? Is that if you want to like just make sure that there's nothing in there?
Yeah, just for the sake of organization. Okay, you see some of those instructions like this. Like, let me go back to the readme. I guess I have things correct. Make sure this cable don't fall again. For the sake of organization, like I should organize my cables better. But for example, I do these kind of comments here. Create a new folder, do like this and that. People, you have no idea of how many of the questions I have that are just like that, organizing this. People get confused, and I know why. It's too much information, too much new information at the same time. So it's difficult to separate what is simple to what is difficult. So I suggest cleaning these files just so that we have a clean state. Look, we enter here. If you're using Cursor, you're going to have this chat tab, but if you're using VS Code, you enter here, it's like a clean state. You don't have anything in contracts, you don't have anything initial in test. It's just a empty project that you can start building with it right now. Okay. So that was the intention here. Good. Okay, so let's start. Sorry for my my little technical problem here. We are going to create a contract called lottery.sol. We're going to create a token that's going to be used as payment called lottery token and a smart contract called lottery.sol. Okay, for us to build this challenge today, we're going to need those two smart contracts. The lottery should implement ownable. I'm going to have that one figure of a single owner inside that lottery. That is the person that deployed the lottery that is going to set a betting price and a betting fee on deployment. These parameters are going to be passed as a constructor parameters are going to be stored there inside the smart contract, and we're using a price instead of a ratio and a fixed fee, a fixed flat fee that we pay per bet that we do. Okay, we're going to understand this money mechanic in a while. When the smart contract is deployed, the lottery is not operational. No one can put bets there. For us to start betting, first the owner should start the lottery defining a block timestamp target. Different from the ballot smart contract that would go forever, this lottery is divided in time slots. So it can open for a day and then close, and then we can reopen in the future for reusing the same smart contract. For the ballot, we would need to deploy new ballots over the time. With the lottery, we can reuse it over the time by closing and opening. This is an important pattern that we're going to see today. Instead of betting with ETH directly, we're going to bet with a token, an ERC20 token. Why? Just for us to test more on the token and on the ERC20 token, like approval, transfer from, burn from, that we did on the week 3. But it would be possible to bet with it normally in that smart contract. The players would pay in tokens to bet, only possible before the timestamp is met and after the owner started the lottery. And anyone could roll that lottery at the end. It doesn't need to be only the owner. Okay, so the smart contract is protected against denial of service. When the players are betting, when they are, let's say I want to bet $10, they would pay this price of $10. They would pay a fee on top of this price where the winners would receive, let's say 10 people bet. I would receive the price that those 10 people paid, but I wouldn't receive the fee that those 10 people paid. The fee is going to be set aside so that the owner can withdraw these fees and restart the lottery. So the money flow is forked, see? Let's say I pay $20 for betting. 10 would go for the prize, for the pool, for the jackpot, and 10 would be a fee that is going to be collected for paying the owner. Okay, the money is forked here. When I roll the lottery, I'm going to pick one winner, and I can only roll the lottery after the block timestamp was met, this timestamp that was set back there. I'm going to pick randomness from rundown, the last rundown review, like we saw yesterday, to determine the winner. And that one winner, just one winner from that lottery, is going to receive all of the betting prices that were collected. The owner is going to withdraw the fees, and then the players can burn ERC20s to get the ETH back, or they can sell this ERC20. They can do whatever they want with this ERC20. Okay. As a reference, I copied this structure from this article that I have here. We're going to see a clever usage of arrays, picking some slots for randomness and all. But I added, what's that? Let me increase this one a little. I added the ERC20 part. I added some different functions. But the base article is this. You're going to have an array of players. Every time someone would bet, I would push the address of the MSG sender inside that array. And every time I want to pick the winner, I'm going to get a random number. And we know that this is not a very good random number. We saw that yesterday. We're going to get a random number and then pick a random player from this index of this array. So every time I bet, I put my address there in that array. I can put it 2, 3, 4, 5 times if I want. And whenever I'm picking the winner, I'm going to pick a random index inside that array. The more times I have my address there, the more probable I am to win, right? So this was the base structure that I based today's lesson. And we're going to build that slowly using the ERC20 and everything together. Okay. We're going to see this pattern of creating contracts. I'm going to deploy the about the lottery token from inside the lottery. We did that different in the tokenized ballot. We did that differently in the token sale, right? We would deploy the token first and then use it as a parameter. Today, I'm going to show a different pattern. We can create contracts from inside another smart contract. We're going to see this. We are going to see how to work with timestamps too, very briefly and quickly, how those timestamps would relate to a block, or the timestamp in the server in the front end is different from the time in the blockchain. We're going to see that too. And we are going to see more about the integers. Not more. We're going to review. Oh, 404. That's so undesired. We had that in the past. Remember the lesson. Which lesson? Lesson 8, I guess. Lesson 8. When we were doing when we did the token sale. 11, I guess. Sorry about that.
12. Oh, token.
This. Did I do wrong? I did something wrong here. Fixing the docs here right now. Sorry about that. This link here is broken. Copy the links that I had in the previous lesson. So we're going to see that, and we're going to see that we're using prices and fees, flat price, flat fee. We're not going to have problems with integer divisions. It's a good review too, okay? So it's not much for a single day. The challenge itself is going to flow naturally. I'm going to show how to do those step by step. We're going to follow this article. We're going to be inspired by this article, actually, when doing this lesson. We're going to see the creating contracts, the timestamp, and the integer division again, solve it. Okay, and this is it for today. We're going to create this lottery token. So we are going to need Open Zeppelin, like Ivan mentioned a while ago. We're going to need Open Zeppelin contracts for us to create this as an ERC20 burnable with access control, exactly like we did in the last lessons. It's not needed for it to be access control necessarily. Okay, I'm pushing that just to copy what we did in the previous lessons. Okay. You could do it as ownable, you could do it with other patterns. But the interesting part for today's lesson is that the lottery token is going to be deployed by the lottery smart contract. We're going to see how that plays out. Okay. So I'm going to start with this smart contract called lottery token. Token. So, and I'm going to create another smart contract for the lottery.sol. This is the starting point. Oh, Ivan, you did the search. You are a gem. Thanks a lot for that. You have the correct link there. Let me do this thing that I'm doing now, and then I'm copying your link. This would be the lottery.sol. The starting point for the lottery.sol with some to-dos for us to complete today. Okay, let me get that link now, Ivan. Okay. Yes, this is exactly this. So that is the bad division. So the good would be multiplier or having a numerator, denominator. They should put the ugly too. The good, the bad, and the bad, and the ugly. What did they change? Compare. It's now on consensus diligence. They changed the domain for some reason. Thanks, Ivan. So we have those two smart contracts. Let's pick up the pace here. The lottery is the holder for the whole logic of that lottery, how it's going to be governed. And the lottery token is holding only the logic of the accountable payable, the money part of it, right? Why shouldn't I do the lottery is lottery token? Remember that? Why shouldn't we mix, for example, the DEX should not be implementing ERC20. The lending protocol should not be implementing ERC20, right? The handler of the token should not implement the token itself, should not inherit from the token. Okay? It should do external calls. We covered that in lesson 11, 11 and 10 and 11 and 12 too, right? So we are not going to inherit lottery from the lottery token. We are going to use lottery token in the line 14 here as an external address for us to do external calls for using this token as payment for the bets. Okay. I'm going to create a purchase ratio that would be the amount of tokens given per ETH paid. We saw that this is bad. It can cause problems. And we're going to use a bet price that would be the amount paid, the amount required to be paid for placing a bet that would go for the prize pool, and the bet fee that would be accounted for the owner pool for the owner to withdraw later. Okay, so we have ratio, price, and price. I could call bet fee price or something like that, but it'd be confusing. This is what I use on bet fee. And instead of receiving the address of the payment token on the construction, I'm receiving the name and the symbol of the token, and I'm going to deploy it on the fly. This syntax is possible. I can create new smart contracts from inside other smart contracts. Let me show a very interesting effect of doing this. I'm going to compile this smart contract. I'm going to take out this new payment token line for now. I'm just going to comment it. Okay. And I'm going to compile this smart contract. Because I made the worst coffee in my life. Every time I take a sip of this, is like a punch in my face. Awful.
That's why it's so good.
The extent we go for caffeine, right? It's getting colder, but whatever. Let's keep forward. We are going to compile this smart contract, and we're going to look under the artifacts folder. You saw this folder a few times in this bootcamp for a specific part called the bytecode of those two members, the lottery token.json. Let me keep it open here, and the lottery.json. Let me keep those two open. The bytecode of the lottery token.json is huge. Up to, if we count the characters, we have here 28,000 characters. Each two characters would be 1 byte. Imagine here that we have more than 10 kilobytes here. More 20 divided by 2, almost 15 kilobytes of information in that smart contract. It's kind of quite a lot, close even to the limit that we can deploy in a smart contract. Okay. Actually, no, I'm copying the deploy bytecode and the bytecode. Let me just get this one. Bytecode here. So 15, 16 characters, 8 kilobytes. Okay. of characters. It's not one by one, but you know where I'm going, right? Yes, Dante, you want to ask a question?
Yeah, how did you get the I guess those sub files underneath the .sol files?
You need to compile the smart contract, and then you're going to see those folders and the JSON files. Okay. Good. Yes, Browns? There is nothing new here, okay, people? We just compile those smart contracts, so there is nothing, no new step that we need to do. I'm just showing a little technical detail. Okay.
Is that NPS hard hat compile? Is it?
Compile, yeah, you can do from the command palette too, like I did here, but you can run from the tab now.
Okay.
So these bytes are from lottery token. Okay. The lottery.json right now, it shouldn't have that many bytes because I removed some parts of it. It's very light. Only about 6,000 characters, like 3 kilobytes only. So it's a small smart contract, right? If I reintroduce this line of code of deploying the payment token from the lottery token, what's going to happen is that all of the bytecode of payment token is going to be held inside the lottery token dormant, like an egg inside a chicken. This amount of mass of volume is going to be there, but it's not doing anything for the whole smart contract itself. It's just there wait to be laid down as a new smart contract, like a closed amount of bytecode, which is kind of bad because it's going to waste space in the smart contract for nothing, for nothing, or for just one thing that is deploying that smart contract later. So if I compile the lottery now with this line of code for deploying lottery tokens from the lottery, now the bytecode is huge. Now, if we copy the bytecode here, it goes on and on and on and on and on and on. Now the bytecode increased for 22, like 10 more than 10 kilobytes of byte, just because I made the lottery token able to deploy the lottery able to deploy lottery tokens. You see? So it is possible. In the past lessons of this bootcamp, we deploy the token first and then we pass it as an address. Here I wanted to show that it's possible to do inside a smart contract, but then we consume too much gas or space in the blockchain for nothing. There are some contract factories, okay, I even put the reference later, that would solve this kind of problem. But we also are going to have some benefits. When I deploy the payment token from the lottery token from the lottery, who is going to be the owner? In this case, the minter, the MSG center, lottery directly. So I don't need to deploy it first and then give permissions. It automatically sort out because lottery is the deployer of lottery token. So it gets all of the controls, the admin roles, and also it's kind of safer, more locked. You see, you can make a contract deploy the order. Okay.
Would you be able to pass this payment token inside lottery to someone else as owner?
Yes, and then I could do something like this: payment token dot grant role, and then I can grant role of payment token meter role to the MSG sender, for example. I can do that in line. could transfer ownership. I can do any subsequent call as I want here inside this deployment function. Okay. Good. Browse, did you solve a problem when compiling? Okay, just copy and paste those two. You should have OpenZeppelin installed too, and it should work, okay, out of the box. So this is the structure for those two smart contracts to communicate between themselves. This is the architecture of this lottery, I would say like that. Okay. Yes, Browns?
Okay, so my question is I noticed that we externally called lottery token. Yes. So why when we uncommented, like we removed the comment from payable token that is equals to new lottery token. Yes, in line 35.
Yeah,
In line
yes.
35. Yes. So in line 35, when we removed it and it was bringing out those warnings. I wanted to know why will it reduce the gas or to increase the gas?
Yeah, when you put this line 35 as it is right now, all of the bytecode of lottery token need to be included inside lottery. All of the byte, even though I cannot call this bytecode to do things that are useful inside lottery, the bytecode is there, is stored. Okay, like an egg inside a chicken, or like a baby inside a pregnant woman. It is there waiting to be laid, but you cannot interact with it from outside. See, it's protected. It's it is in a kernel, in a womb. It is a place that you cannot access the bytecode there from outside, but it can be used for replicating, for creating. It's like a mode. It's a mode for creating new smart contracts. You see, so this is why you spend more gas, because you need to create that mode there.
Thank you.
Okay, so this is the architecture of the lottery. It's able to deploy this new lottery token. So I have a script, a CLI style script, like we saw yesterday, that I'm going to put inside my scripts folder, which I don't have. So I need to create a script folder. Scripts. And then I'm going to create this one file there with this huge CLI script, this preparation script with a lot of to-dos. This is script code reference. And let's name it test lottery, or let's name it lottery.ts. Okay, because it's going to be a CLI script that I can use for interacting with the lottery. Everything that we do here in TypeScript using VM, you can now port to your front end using Next.js, using Scaffold, or using whatever you want, right? Using Angular, using Vue, whatever framework you want to use, so long it has compatibility for you to install VM there, it should work. Okay. So let me copy that script. And we're going to use that read line kind of CLI menu feature that we did yesterday to guide us to interact with those pieces of that smart contract. Okay, so importing VM from Hot, pass ether, format ether, and address from VM, and everything is readline from readline as we did yesterday. Okay, so I do have this main menu function where the user can select an option. Is going to go for those different functions as I have here. Case menu 8 is going to do something. 7 is going to burn. 7 is going to withdraw. 6 is going to claim the prize. So I have prepared all of this CLI logic already. Could be some dialogue that you have with your end user should be something that you are going to implement in the interface to in this weekend project. And this is the menu that I'm giving for the end users, okay? Before I start this menu, I need to implement the init account, the init contracts that I have here in my memory of this script. When you use there in the front end, you should have a class or something to store this in memory to when you are running the application, right? Or you can use state management like React state management. No? You're going to have those objects. And then we're going to pick those options, those menu options here to interact with the smart contracts. Okay. Let's do these two first. Before we start understanding those functions here in this smart contract, let's do this first, that is agnostic. I want to init accounts inside this. I should have a variable here, right, for these accounts. Let me see. Init accounts and init contracts for us to use in the tests, right? Let me go for the solution. Init accounts, get accounts. I changed the name from init accounts to get accounts, it seems. That's funny. I didn't remember that. So instead of init accounts, we're going to call it get accounts, get clients, and init contracts. So those three functions. Nothing new here, right? Get accounts, it's going to use VM get wallet clients and return those pre-funded wallets that we have in VM. We saw that in week 2, we saw that in week 3. Nothing new. When you do that in the front end with scaffold 8 now, you remember what you're going to get? The list of accounts that you have interacting there with MetaMask. Okay, the amount of wallets that you connected. You can connect more wallets at the same time. It's possible. You can link 2, 3, 4 wallets. Usually this array is going to have only one wallet that the person linked. You pick the first one. Okay. So this would be the get account. Get client, the same thing. You get public client with VM here. Sorry about that. I guess the coffee was so bad it made me sneeze. You're going to get the public client. When we're doing here, you're going to pick the connection that you have with hard, the things that you configured in the hard config, Sepolia, hard from time environment, whatever. When you do that in the front end, you're going to get the public client, the connection that MetaMask has to the blockchain, right? And then here in this script, I'm initializing contracts by deploying the contract lottery with the account that I have here in hard. If you're doing that in the front end, you would have deployed that already, you would have that address for you to connect to. Okay. So let me go ahead and change that boilerplate code that I have in the README, because I changed it in the implementation and forgot to change it back. Sorry about that, people. I should have paid more attention when building today's lesson. So actually, I named it get account and get clients. I'm going to commit those adjustments. Yep. Yeah, it's just that there's so much complexity. Sometimes these polishments they can reduce the amount of things that you should pay attention to. Let me commit this. Right, link and the function name change. That's good. AI is so helpful nowadays. Dangerous, yes, but helpful too. So if you pull the changes, you should have those fixes there. We're going to have this get accounts, get clients, and init contracts. Okay. I know we covered this a while ago in this bootcamp. We did this a few times already, but this is always good to ask. Any confusions here on using VM from hard? versus using VM inside the front end with Scaffold ETH or any of those frameworks. If you did a last weekend project, you might have interacted a lot with this, like from the front end, you use MetaMask, but when you are in the back end with Nest.js, you use the hard-coded or the .env wallet, and you probably know how to handle those credentials, those connections, different places by now, right? So let's get to the actual implementation. First thing, I want to check the state of this lottery. Let's read the problem statement again. What kind of states I can have in this lottery? I can have the lottery was created but did not start yet. I can have the lottery was created and it was started. And I can have the lottery was created. It has, in this case, in the second case, would have started and not finished yet before the block timestamp. And the third case, the lottery was started, it was created, was started, and the timestamp has passed. So I would have those three states. After the timestamp has passed, anyone can roll the lottery, and the owner can reset the state to the state one again. 1, 2, 3. Oh, more precisely 0, 1, 2. Okay. Those three states they could be an enumerator, an enum flag, a variable that I have in this smart contract, and they would change up to some events, right? The problem is there any way in the blockchain to have a cron job or a schedule job or something that's going to execute in the future? When this timestamp is met, it's going to change the state automatically from phase 2 to phase 3, from open to closed. Is there any possible way for someone to sign a transaction today and the effect of that transaction happen in the future after some blocks? Is this possible? With events, well, events would give us logs when this happen, but it wouldn't change the state of the blockchain, right?
Not without modification, right?
Yeah, because every modification in the blockchain, every state change, it needs to come from a signed transaction, right? So there are some techniques like the workers from Chainlink and blah, 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 that you can ask someone to go in the future and change the state of a smart contract. Yes, it's possible. But by design, bare bones, Ethereum, EVM, there's no such feature that we can go in the future and change UINT from number 2 to number 3 is scheduled. I would need to do that transaction. So it is very common whenever we have time-dependent logic to have time functions. How much yield has this token accumulated? For example, you put your money there with AV. It's going to accrue yield block by block because the yield is a time function. It is a calculation that you can do every block just by asking the blockchain. And they do this calculation there on the line. So here in this smart contract, I'm going to suggest an implementation where I'm going to have a function that can open bets and some modifiers. I didn't include them yet, but I'll have some modifiers that are going to embase this decision. And then when I have the script here asking, what's the state of this lottery? Is it open or is it closed? I'm going to join more information. I'm going to join more data points and not just a flag. Okay. In the smart contract, we have here these variables already: payment token, purchase ratio, bet price, and bet fee, right? I'm going to add another flag. It's going to be called, I don't remember the name, it's going to be called bets open. It is a flag indicating whether the lottery is open for bets or not. When I open bets, the first thing that I should do is make this bets open equal to true. Now, people can bet. Later in the bet function, I'm going to require bets open to be equal to true, right? But there are several conditions here that I should meet, sorry. First, this should be on the owner. Why? Let's read again the description. Maybe I should open this side by side. Only the owner can start the lottery, and it should define a block timestamp target. So first thing that we should put here, only owner. We should have a way for the owner to pass this block timestamp, right? It should have a way for the owner to define a timestamp target. There are two ways to do that. Either I receive the timestamp correct that I want to close this lottery, you reach 256 timestamp. I guess this is the way that I have in the solution too. I have this timestamp here. Open bets. Closing time. Yes, the timestamp of the closing time. So the timestamp of the closing time. And this is a very good way. I'm going to explain why. Or I can have a duration. The closing time is exact. I want the bets to close on Friday at noon Brazil time. Or I could do a duration. I want the bets to close in 26 hours from now. You know the difference from those two? Let me copy both here, side by side. So let me do like this, like that. I can open bets passing a duration, or I can open bets passing a close time. Okay, Arda, you have the answer? You want to ask a question before we go?
Both.
Okay, shoot.
But what do you mean by duration? The duration after that this contract is deployed or open bets is called?
Yeah, when I call open bets, I can call it like this. I want the lottery to close at this time, or I can say I want the lottery to close at this duration, and then the closing time would be the block timestamp, the block timestamp plus duration, right? So there is a difference on those two, a very important difference that I wanted to highlight. You want to ask something, Arda, before we proceed?
Yes. About some sort of blockchain semantics. Should we use block number or time duration? Because this time stuff can be manipulated because the timestamp can be in the middle of creation of two blocks, right?
Yes, this is correct. So anyone could make the lottery close 4 seconds after or 4 seconds before when they can be manipulated, right? So for example, for randomness or for small tweaks, this is super important. We're going to see that happening in a vulnerability on the lesson 24 too. For longer time windows, for example, this lottery is going to close a day from now or next week. These 4 seconds, they are almost harmless. it doesn't make so much difference if it closes 4 seconds after, 4 seconds before. For the end users, it's going to be almost imperceptible, okay? Maybe they can push the closing time after to include a few bets, last minute bets, right? No one was betting, then everyone bets at the last time. And then the miner can say, there are too many bets. I'm going to close that sooner so that those people are going to be left out. It is possible, but the effect here is neglectable because people had days to bet. Those 4 seconds at the end are not going to be that much important, okay? But it's true, whenever you're doing time-dependent logic, for example, a game, those 2, 3, 4 seconds that the miners can manipulate, they can be very important. But for this example that we're dealing with days and weeks, it's not that relevant at all, okay? For this block, using block number and block time would be almost the same. When I do block number, I know exactly. The problem of using block numbers is that sometimes the blocks they come faster and other blocks come slower. So it seems a little unprofessional for Web2 people when you say, oh, the event is going to happen around 10 and 10:30 or something like that. They are like that. Why don't you define a specific time for this thing? Oh, you can bet up to midnight, give or take half an hour. So this is not so professional. Ideally, we would be able to set a time, the exact time for this event to happen, regardless if the blocks were faster or slower within the middle in the meantime. Okay.
Do you know of any practices that would use both the block number and the block timestamp, like the closing time? Would that be something to implement?
You can join both. For example, it needs to be at least after this block and at least after this time, something like this. But you cannot ensure that this block is going to happen at that time. You can always move back and forth. Okay, but now let's go back to this difference on duration and closing time. When you set a closing time, the time is going to be respected regardless of anything. When I set a duration, this transaction might take a few minutes to be included in the blockchain. Let's say it takes 2 hours. The blockchain is super congested. I put a low gas price and I sent this open batch with the duration of 1 day, but this took 2 hours to be included. The closing time is going to be the block timestamp at the time that this transaction is included, you see? And then plus this duration. And even worse, this could have a reorg. And then the block timestamp can change from a time to another depending on the reorg that this happened. So it is variable, volatile. This closing time could change depending on the block timestamp when it was included. I know that this is better for the end user. I just do a duration. I don't need to calculate the closing time, blah, blah, blah. But you can do this conversion in the front end. I'm going to show that. So whenever using timestamp of events of things that are going to happen in the future, it is better to pass the exact time in the exact time expressed in seconds, no milliseconds. Usually when we do it that in server, in front end, it's milliseconds. We're going to see that. But we're going to see in the number of seconds elapsed since January 1st, 1970. Okay. What if you want to use historical events before that? You want to make a smart contract about the happenings on the Middle Ages or the Roman Empire or something like that, on Egypt, then you cannot use this kind of timestamp representation, okay? This is for modern computation that happened after 70s. This is the timestamp that we're using here, okay? So how we're going to implement that? I'm going to copy from the solution, and then I'm going to explain. I'm going to have this function open bets. And I'm going to use two modifiers for helping me with these functions. I'm going to have the function open bets, that is only owner, and I'm going to require only when bets are closed, this modifier would say not bets open, semantic here. So if the bets are open, I cannot open this lottery again, passing a new time. That would bug the people using that smart contract. And I'm going to set the closing time as exactly as passed as a parameter. Okay, I'm not going to calculate this duration here. And then I'm going to set the bets open as true. Okay. For that, I'm going to need this bet closing time variable. I'm going to copy here from the solution to this bet's closing time. That is the timestamp of the lottery next to closing date and time that is going to be stored inside this smart contract. Okay. Good. Someone raised their hand to ask a question while I was typing. I couldn't notice who was that.
It was me. I just wanted to say conceptually, what's going on is you're grabbing the block timestamp once, and then your duration is changing in comparison to that, like relative to that. Are you getting the block timestamp once, or like are you taking snapshots and then you're calculating how much is left, and that's your closed window?
Exactly. Every time if I want to know if the bets are open or not, I can calculate the operation of the bets open flag, that is definitive, and block by block, I can ask this question: is the current block timestamp before the bet closing time? Yes, it is. So it returns true. Yes, it is. So it returns true. And up to a point that suddenly it's not anymore. The block timestamp passed the bet's closing time, and then this returns false, even though the flag bets open is still true. Since this is false, bets open are going to deny. It's going to return false, even without spending gas for this operation. Just because the block timestamp is being incremented at each block, this is eventually going to happen naturally. So you don't need to call the smart contract when this happens. Naturally, it's going to be used when you do these computations. Okay. Ivan, you want to ask a question here? I can't hear you. Maybe you're muted. Maybe some connection problems. Okay. This answers your question, Dante?
Yeah, thank you.
Okay, okay. Ivan, I see your hand raised, but okay, maybe some connection problems. You drop. Okay. So to test that in this script, I suggest a way for you to convert those back and forth, convert timestamp to milliseconds and to server time or to front-end time by using these functions from JavaScript. They work in TypeScript too. Let me copy and paste here to my script. Check state. So when calling this bets open flag, it's going to give me information directly. Let me cut this out for now. Let me compile this smart contract, cut this out, and start with this check state function. Very simple. If the bets are not open, this is going to give me false. and then the state is going to return closed. If the bets are open, it's going to return true, and the state is going to return open. Okay? I have an open mic here. So if I ask this script as it is right now, let me run it here. npx red hat run scripts lottery.ts. This string conversion is going to be very simple. The bets are going to be false. Max event has already been declared. It seems I did something wrong. Yes, I did something wrong. Yes, I failed when copying this text. I copied everything instead of just the check state. Sorry about that, people. So check state. I'm going to do just this part for now. Okay, so check state is going to return lottery is closed. See, I read the Boolean and it's closed. There's not much mystery. Okay, I'm just asking the smart contract. Now, if I have this bets open, I'm going to implement this bets open bets function in a while. I can get the block timestamp, current block timestamp. I can get the closing time from the smart contract with this variable bets closing time. And then I can display it like this with JavaScript. The end user doesn't know about timestamp, epoch, and blah, blah, blah. They know about clock, about dates. So in the front end, you need to do some sort of conversion like this. Imagine like a countdown or some timer like this. And you can do using those functions to local date and to local time. It's possible. You just need to remember that when you use the date object in JavaScript, is using Node, is using your browser, whatever, it is going to pick the value in milliseconds. And in blockchain, we always account things in seconds. So you need to multiply the timestamp by 1000 whenever passing it for creating that date objects. Okay. Good. Let me show that first, and then I go to your question, Yvonne. Okay. Let me implement that, or the function of open bets. That is basically calling that smart contract to open bets, and I'm doing that conversion that I mentioned. The user can pass this duration as a string, as a number, you know. I'm going to calculate that off-chain. I'm going to pick the current block timestamp, and then I'm going to write open bets with that specific timestamp and that duration in seconds. Okay, in seconds. And then this is going to create that transaction in the smart contract. This is going to lock the final date, that final position in that place. Okay. Let me run this script again. I'm going to do the number one, bets is closed. Then I'm going to do the number two to open bets. And then I'm going to do the number one again. Number one, bets are closed. Number two, open bets. With which duration? Let's put 100 seconds. And then if I check state again, look at the formatting that I have. The last block was mined at 11, 11, 11. Nice. Didn't do that in purpose, but in Brazil, it's by morning 11, 11 here. And the lottery should close at 11, 12:40 a.m. Brazil time, using my local time. And if you put that in the browser and another person accesses the same website from Europe, from Russia, from Australia, from whatever place, it would convert to their own local timestamp. Okay. Good. Now let me get to your question, Ivan, about the closing time. when we set the closing time with a timestamp, it is determined, right? If I send this transaction, it could take 2 hours for being included in the blockchain. The timestamp is determined. It's going to take 2 hours to be included. And so instead of having 24 hours of this lottery open, it's going to be 22 because of the delay of the blockchain. That is true. It's unlikely, but it can happen, depending on the fees that you put and all. The same can happen around the closing time. If the network is congested, some of the bets that are put there before the closing time, they can be delayed. And then when we're going to get to this bet function in a while, we're going to see that we do have a requirement for it to be open. Show that for you here in the solution. So bet. So I have a requirement that it should happen only when bets are open. So I can send the transaction before where I have this modifier, when bets are open. I can send the transaction before the timestamp reaches the bet closing time, right? But nothing guarantees that it's going to be included in the blockchain before of that. So there is a front-running possibility there. It happens a lot in NFT auctions or even order to decentralized exchanges, where the miners, they can manipulate the block timestamp to close something sooner or to push something forward within those 4 seconds as they see those transactions in the mempool. It can happen, okay? So it incentivizes people to send transaction with a lot of gas fees to make sure that they are included very fast. And this is why we have these spikes in gas fees all the time, because of people desperate to include the transaction. They have a lot of money to lose if the transaction is not included soon. So they pay a lot of gas, a lot of price per gas for having the transaction included as soon as possible. So it can happen, okay, Ivan, Arda, you are correct. It can happen that when I send a bet, it gets delayed to be included, and then I don't get to bet just because of the network condition. I sent it before the closing time, yes, but it was received after. Okay. Imagine a couple centuries ago when the submissions for things were letters. Send a letter for this castle, and you are going to be included in the tournament of the best pumpkin pie. A pie. Who can do the best pumpkin pie of the county? And then you send a letter, but the postman takes 2 weeks to deliver because he broke his leg, and then you receive a letter back saying, "Oh, sorry, your submission cannot be accepted because you subscribed after the deadline." And then you say, "No, I sent the letter before, but the postman broke his leg," you know. So this problem that happened in the past with postal service would happen in blockchain times because of the delay of the network confirmations. Okay, it can happen. Okay, so the close time is respected all the time because it's going to be combined with the block timestamp. It's just that the bets included or not, they can change. Okay. So we have 15 minutes of today's lesson. Let me place the whole script here to explain you this smart contract, how we will go. Put the smart contract first, of course, and then let me put the script, the solution, and then you can follow through this. Yeah, it's a long script. If you have the time, please don't copy and paste like I'm doing. Go for each of those to-dos, making sure that you understand the whole code, you understand the process that are happening. Okay. We went up to check the state and open bets. So we went up to line. Let me fold these. A lot to fold. Up to line 191 of the solution, and we understood how we open bets and how we could check the state of the smart contract, right? Now I want to do the financial part. I want to display my balance and I want to be able to buy tokens. Now you look at your lesson 10, how we implemented that in lesson 10. So let's go for this function here. In this smart contract, you're going to see that this is something very similar. Purchase tokens. I'm going to pick the payment token and mint for whomever send this value using this ratio. And we studied that in lesson 10 and 11, that the ratio can be a problem. Down there, when I burn those tokens, when I want to burn those tokens, I'm going to do the opposite. I'm going to call that function return tokens, but before I need to approve. This is a very important piece of review. So when I want to purchase tokens, I can just mint and I use payable. But when I want to return tokens and burn them, I need to approve them first for me to do that burn from. And then I send this ETH, okay? So this function, let me fold the orders. I guess it's not going to fit in the same screen, but let me try. So these two functions, open batch purchase tokens and return tokens. Stop it, I can just do that while I'm zooming out. Purchase tokens and return tokens. Is that clear for you? Remember that from lesson 10 and 11? You can pay in ETH using payable, but for paying with the ERC20, you need to approve first and then you do a burn from. Okay, you can copy that as it is from the token sale, right? No, we did that, and then there is this problem when we have this division, we could lose some decimals. Okay, it's just a review. It's here on this monetary part, just as review of what we did in previous lessons. Okay. So how we would implement that in the front end? You would have a function for you to call and buy tokens that is going to call the purchase tokens function from the smart contract. This is part of the homework. You need to implement that in the front end, calling this function for purchasing tokens. And then you have this other function to burn these tokens. Okay, we show those in practice. Okay, so let me top up my account with tokens. Number 3, let me use my account. Let me use my account 1. The account 1 has 10,000 ETH. It's a pre-funded account. Okay, how many tokens I want to buy? Let me buy 100 tokens. So we bought these tokens. We have now 100 less ETH and 100 more lottery tokens. Now, if I want to burn these tokens, I'm going to use the account 1 again. And let's say I want to burn 50 tokens. Now I have my ETH back, plus minus some gas fees that we paid. And we could sell back 50 of these tokens that we had. Okay? This is basically a review from the week 3. We used this in the token sale. Now I want to bet. Let me bet with the account 1. What is missing? I do have the tokens. I have 50 LT0s. Let me bet once. I forgot to do what?
Open bet.
Yeah, it give me this error. So lottery is closed. Okay. So now going for the explanation with the smart contract. I have implemented the bet function. Let me fold the purchase token. Let me fold the return tokens. Let's focus now on the bet function. I have implemented the bet function so that it's going to require when bets open, which is not there, when I bet, I pay a bit of money to the owner pool that's going to be used later for the owner to withdraw money from that smart contract. And I updated this value of the prize pool that is going to be used whenever someone is going to withdraw the prize, or actually whenever someone wins the prize, line 110. We're going to get there. We have almost 10 minutes. So this is the bet function. To keep track of how many bets we had, we have this slots array. This is the thing that I mentioned from this article, how to create a lottery smart contract. So they suggested us to create this array of addresses, and then every time a player would bet, I can just push inside the array of players the MSG sender. So if I bet 3, 4, 5 times, this array is going to have my address on 3, 4, 5 of those slots. Okay. This means that the lottery is fair. I bet 5 times, you bet twice. So 7 bets. I have 5 divided by 7, you have 2 divided by 7 odds of winning. Okay. I paid more, you paid less. So it makes sense, right? Up to this point, on open lottery, check state, push these tokens, burn tokens, and bet 5 functions. All good here? Can you follow the idea? Let's take a half a minute. Let it sit, ask questions.
Bet only bets once, and then bet many uses bet that many times so that every slot is occupied with one bet, right?
Yes. And this is one of the bonus for today's lesson. If you have time, organize, document, and optimize this smart contract. Because as you can see here, we have a loop while times, and let's say I want to bet 1,000 times. I might hit the gas limit, right? What if I look at this? I'm betting 1,000 times, but I'm summing the owner pool by the same fee 1,000 times. Wouldn't it be better just to multiply by 1,000, do this operation once? Okay. So there are some optimizations that are possible. This is a bonus. If you have a lot of free time this weekend and you want to optimize this smart contract, you can work on these functions too. Okay. I've left a lot of situations like this for you to play along with this smart contract. Okay. Questions about this bet and bet many? Okay. May I proceed? I'm counting on like 6 people with the camera open to get the facial feedback. Delta, you did a thumbs up. That's okay. Conrado nodding. Okay, good. Yeah, I have a monitor where I look at the cameras here, trying to sense how the lesson is going. So this is my only stream of feedback. Yes, Ula Smith, tell me.
For example, for this bet many times, if we will do, as you said, for example, bet fee multiply by 10 or how many, doesn't matter, price also. Is it possible to push to the slots like what is will be the best gas optimized way to push 10 times the sender to the slots?
Yeah, this is a very tricky question. I wanted you to explore this. So that is creating a new array with this. It's joining arrays. There are libraries for that. There are other ways for accounting for those bets without using arrays that you just do an index map. Okay. You can map the amount of bets per sender, and all of those would have different gas optimization. If you don't want to get there, if you want a quick answer, the answer is depends. Sorry about that. Because you're going to see that in some occasions, some strategies are more gas efficient, and in other occasions, other strategies are more gas efficient. If you have a lot of bets per players, it's better to do a mapping. But if the majority of players only bet ons, this is more efficient. Okay, but this experimentation is very good for getting the tone of gas optimization.
Can I ask one more question?
Yes?
If we will have like many players will make a bet in the same block.
They can do bets in many different blocks. That's not
No,
a
I
problem at
mean
all.
like two different players will send the transaction and it will enter into the same block.
Yes.
So all of them will get the same copy of, for example, slots. Yeah.
Actually, no, the slot is calculated per transaction. So the transaction it's unaware that it's in the same block as other transaction changing the same smart contracts. They would be processed in the same way, even if they are in different blocks.
Okay.
It is atomic. Make sure that everything works. What you don't know is the order of those transactions. Maybe you're going to have the first slot, maybe are going to have the second slot, you don't know. Even if you send a transaction before and the other person sends a transaction after, but if they get included first in the block and you later, you get the second slot. Okay? But here, the order of the slots is not a big deal. Okay.
But each block can have like many operations, yeah?
Yes. But this is
it's
not a problem
impossible
for
to
the...
have.
Sorry?
It's not impossible to have many operations for the same contract in the same block.
You can, because after each transaction, we have an intermediary state that is stable and permanent for that block.
Okay, I get it. Thank you.
Okay. So when closing the lottery is very straightforward. I require the block timestamp to be higher than the closing time, as we had in the challenge explanation, and I require that to be open. Otherwise, I can say it's already closed. And then I'm going to do this calculation. It's not a requirement that only the owner call this. Anyone can call this, especially the winner. If the winner knows that he's going to win, he's going to call this function and pay for the gas. Okay. Because if the owner is playing that lottery and if he simulates that transaction and he sees, oh, I'm not going to win, so I don't want to play this lottery anymore. If I do it only owner, it would be bad. Everyone would be locked in here. So usually those kind of functions that are going to impact the end user and they don't require any sort of accreditation, you can make it public. So anyone can enroll. I'm going to get the random number from rundown. Ideally, I would have a cliff period from the closing time and getting the randomness just to make sure it is safe. But here I implemented very quickly without this cliff period. You get the random number, you divide by the number of slots that you have, and then you determine the winner. Then you distribute some prize for the winner. This winner could even have prizes from before, and then they can withdraw it here. Random number we covered yesterday, and that would cover the lottery. Okay. Like the owner can withdraw, I mentioned that, and the return tokens, I already mentioned that. We finish exactly on time, maybe 1 minute extra. But this is today. This is everything that we had today. The lottery, the smart contract is there, is given. If you have the time to complete it with your team, would be great. The script is given. If you have the time to complete it with your team, is great. But you can pick the things that we did in the script to do the front end, and then you are going to implement that the app for buying, returning tokens, view and placing bets, running the lottery, checking the lottery state, view and claiming the prize, the lottery administration pane of starting the lottery, setting the timestamp and all. And if you have some extra time, do the optimization, organization, documentation of that smart contract. Okay. That's it, people. I hope you have a great weekend. Almost finishing the front part of the bootcamp here. This is going to prepare you very well for the final project in a few weeks from now. Okay. Any questions, as always, feel free to reach on GitHub, on the technical channel, on Discord, and we talk again on Monday. Okay. Thank you, people. Bye-bye.